All right, here you go. You ask and I deliver. You asked me to go step by step, very slowly over more examples. So I got my little notebook. This is an extra notebook. I'm just going to fill it up. So this is factoring more. More examples, more steps, more notes. Let's do it. Are you ready? I'm ready. All right. I should have put an f of x in front of this, but I forgot until I already wrote it down. So just bear with me. Okay, so I have two terms. It's probably sum and difference of cubes. Let me just check before I go in there, though. I noticed 8 shows up a lot as a cube. I know that x cubed is a cube, and then 1 times 1 times 1 makes 1. So that's how I identify what I'm doing. There's 1, 2 terms, so it's probably sum and difference of cubes. So let me go over there to this one. So this is a sum of cubes because there's a plus in the middle. So this is a sum of cubes, which means that my formula is that a cubed plus b cubed becomes a plus b times a squared minus ab plus b squared. So that's on this page right below me. Okay, so I have to identify what a and b are. So a is whatever cubed, sorry, a cubed has to make negative 8x cubed. Well, then a would be negative, because we'll talk about that in a second. So 2, because 2 times 2 times 2 is 8. It's down over there. Negative 2, and then x. So if 2 times 2 times 2 is 8, then negative 2 times negative 2 times negative 2 is 8. If you don't believe me, ask your calculator. This is also basically the same thing as being switched around, where a would be 1 and b would be negative 2, and then you could do the difference of cubes, but don't worry about that. Just ignore that part. b is 1, because 1 times 1 times 1 is 1 down here. Okay, so this was my starting point, and then this is what my answer is going to be. So a plus b, so negative 2x plus 1 times, okay, well, a squared. So if I do negative 2x and square it, I have to square the whole thing. Train's coming. Minus negative 2x times 1 plus 1 squared. So that's the whole thing over there. I just plugged in a and b. And then I have to clean this up just a little bit. This one's fine. Choo, choo, choo. Okay, so the negative 2x times negative 2x would be a 4x squared. And then this, if I put this all together, negative 2 times 1 is negative 2. But make that negative, so I'm going to do a plus 2x. And then plus 1. And that's it. I can't factor that anymore, I promise. You can never factor these more. All right, let's do another one. Let me find a good one. Hold on. Okay, let's do this one. X to the 5th plus 8x squared. Again, I should have written the f of x. Dang it. Okay, well, both of these have an x squared in it, so I can take out an x squared. I'll be left with x cubed plus 8, which looks a lot like the kind of one that we just did, except there's an 8 on the end instead of the front. So let's see. X cubed is x cubed. 2 cubed is 8. Yeah, this is a sum of cubes. I'm so sorry. I told you in class I needed to take a nap, and I never did. Okay, so if it's a cubed plus b cubed, that's going to equal a plus b times a squared minus ab plus b squared. Okay, well, a would be x, because x cubed makes x cubed. And b would be 2, because 2 cubed is 8. I'm ignoring this x squared in front, by the way, because it's like an extra thing. It's like the in front of, and it's not part of this anymore. It's going to end up in the answer right here, but we're going to ignore it for the sum of cubes part. All right, so then we get x squared still from here, but then this becomes this. X plus 2 times x squared minus x times 2 plus 2 squared. And then I clean that up for a whole step. Still x squared, still x plus 2, but then this one's going to be x squared minus 2x plus 4. Great. All right, let's do another one. All right, let's factor this one. 4x cubed minus 8x squared plus 3x minus 6. This one is no longer like that one because that one had to have 2 terms. So let's go back to that main screen. Let's see. Looks like there's 4 here. And I can't divide anything out because I always check for a GCF first. But I can't divide anything out, so I'm just going to go for the 4 terms. It's even number terms. Let's try factor by grouping. So factor by grouping, I take it in chunks. So I take the first chunk, which is this set, and the second chunk. And out of each of those chunks, I take out the greatest common factor. So here, these can both be divided by 4, and the lowest x is an x squared. So I'm going to divide 4 and 8 by 4, and I'm going to take 2 away from the powers. So this is actually just going to be an x, and that's going to be a minus 2. It's 2 because 8 divided by 4 is 2, and x squared divided by x squared is no x. All right, and then I can take out a 3 over here, and I'll be left with x minus 2 again. Neat. These are the same, so I'm going to take them out in front. X minus 2, and then I write what I'm left with after that's gone. 4x plus 3. Sorry, 4x squared plus 3. Sometimes I can go further with this one, but I can't go any further with that specific term right there. So that's actually the end. But if I ever see a power 2, and I didn't use sum and difference of cubes, I should double check to make sure I can't do it any further. Let's try another one. Okay, let's try this one. So I have 4x cubed plus 3x squared minus 12x minus 9. If I didn't have this 4 in front, I'd be able to divide all these by 3, but I have it in there, so I can't do that. And there's no x on the end, so I can't divide anything by x. So I'm just going to start with my synthetic division, or sorry, my factor by grouping again. So I'm going to group this set and this set. So this is, I can take out an x squared out of here, and I'll be left with 4x plus 3. Again, I'm doing it by dividing both these things by x squared, which means I take 2 away from the power. And then both these can be divided by 3, kind of like I said before. And so I'd be left with, oh, look, 4x plus 3. I took out a negative because they could both be divided by -3, but also because I knew I wanted a plus in the middle and I needed it to be positive there. Okay, well, look, those are the same, so I can take those out in front. 4x plus 3, and I'm left with x squared minus 3. Cool, we did it. All right, let's try another one. And I'm going to use this space over here because I have so much room. But if you need to use the next page or if you're just following along to watch, that's fine too. I don't care. I'm not going to tell you you're wrong. All right, let's do, where was the hard one I found? Well, that's my opinion. Don't ask me to lie. Well, then I have to find it. All right, I found it. So we're going to do 5x cubed plus 4x squared minus 5x minus 4. Once again, I'm starting to kind of tell that when it has the same number twice, it's going to be factor by grouping, but you know how these kind of can divide both by 4 and by 3 and so on and so forth. But that's something that I get like a sense about when I do these, so you probably don't have it yet. That's okay. All right, so we're going to group these. I can take out only an x squared out of this. And I'm left with 5x plus 4. And then over here, I can't take out anything, but maybe a negative would be good because I want to take a negative out for this. And that's 5x plus 4 now, which is what I wanted. So I can take that out in front. I have 5x plus 4 times x squared minus. That's where people get confused about what to put here. I'm doing minus 1 times this, so it's x squared minus 1. Remember earlier when I said you had to double check to see if you could factor this one? It's because you can actually factor this. This is a quadratic where x squared and minus 1 are both squareds. So I can do an x puzzle with -1 on top and 0 on bottom. And that would be -1 and +1. So this part is actually x minus 1, x plus 1. So what my answer is 5x plus 4 times x plus 1 and x minus 1. Let's do another. All right, let's do this one. So this one I have 3x to the 6th minus 5x to the 4th minus 12x squared plus 20. I can't divide anything out again. Sometimes I can, so I always have to check. but I'm going to group the first half and the second half. So this first half, I can definitely take out an x to the fourth. And I'll be left with a 3x squared minus 5. And in the second half, I can divide both of these by 4. And I'll again be left with 3x squared minus 5. Okay, so that's the same in both of these. So I have 3x squared minus 5 times x to the fourth minus 4. This is another one where I can actually keep going. X to the fourth minus 4 is kind of like an x squared minus 4. And so it would be negative 4 and 0, which is negative 2 and 2. So x to the fourth minus 4 is actually x squared minus 2 and x squared plus 2. If that was confusing, don't worry. That's confusing every year. It's not just you, I promise. If this whole thing is confusing, please come to office hours so I can do this in front of you so you can ask me questions as we go. Because I don't always know what the questions are going to be. Especially like, why did you just write 5? I don't know where the 5 came from. Oh, it probably came from here. Or up there. All right. Let's try another one. I'm going to switch my page over as I'm running out of space. More examples. I'm not going to write it yet. Okay, let's do this one. Here we go. All right, once again, I really just want to be able to use factor on greatest common factor, but there is none. So instead, I'm going to factor by grouping. All right, out of this first half, I can definitely take an x to the fourth out. And I'll be left with 3x squared minus 5. And then over here, I can take out an 8. Maybe even a 16. Let's check. So I'm going to use my calculator. And I'm going to do 48 divided by 16. Ooh, is 3. Good. And 80 divided by 16, which is 5. Great. And those are pretty small numbers, so I can definitely keep them that way. So minus 16. And then I'll be left with 3x squared minus 5. That's what I wanted. So I can take that out in front. 3x squared minus 5. And I'm left with x to the fourth minus 16. Once again, 16 is a perfect square, so I can actually factor that more with negative 16 and 0, which is negative 4 and positive 4. So I actually have 3x squared minus 5 times x squared minus 4 and x squared plus 4. But watch this. X squared minus 4 is another one like this. I can keep going. So I have negative 4 and 0, which is 2 and negative 2, which gives me 3x squared minus 5 times x plus 2 times x minus 2 times x squared plus 4. Why can't I do that with the x squared plus 4? It's because it's the special case when it's negative. When this is positive, I can't make those two numbers add up to make negative 4. Or 0. 0. Okay, so that's the end of that one. Let's do another one. Let's do one that is probably quadratic. Actually, these are all probably quadratics. Let's do one that's synthetic division. Let me show you. All right, here's a longer one. It actually has 5 terms. So it doesn't work for any of the ones that we've done before, but it does tell me that x plus 2 is a factor. So what that means is that I can do synthetic division using a negative 2 and all these numbers. 2, because that's power 4. 3, power 3, negative 4, power 2, negative 3, and 2. And that all is in order, and there's no 0 because there's nothing missing. And I do synthetic division. Drop it down. And then we multiply and add. And there's a hair in my pen. Multiply, that's negative 4. Add, that's negative 1. Multiply, that's 2. Add, that's negative 2. Multiply, that's 4. Add, that's 1. Multiply, that's negative 2. Here we go. That's 0. And 0 is what we wanted. So what I have is I have x plus 2, and then I have all of this. 2x to the third minus x squared minus 2x plus 1. That has 4 terms. It's an even number of terms. I can probably do factor by grouping now. So I'm going to factor group this part and this part. And I still have x plus 2 just kind of chilling. But out of this one, I can take out an x squared, and I'll be left with 2x minus 1. And out of this one, I need this to be a minus 1, so I'm just going to take out a negative, and we'll be left with 2x minus 1. I did giant parentheses so that way you'd separate this in your mind from here. Okay, so then I have x plus 2. And then here I can pull out the 2x minus 1. And then here I have x squared minus 1. And then I can do a little x puzzle with this one, with a -1 and 0, just -1 and 1. So I get x plus 2 times 2x minus 1 times x minus 1 times x plus 1. Do you want to try another one? Okay, let's do it. All right, let's try this one. I left the ending just says x minus 2 because I wanted some space over here, but it should say x minus 2 is a factor, just in case that helps. Okay, well, I have a lot of things, but I do know one of the roots, so I can do positive 2 on the shelf. And then 4, 3, 2, 1, 0, we're good. So I just take the numbers in front, the coefficients. I almost said a plus 7, so I just made it a weird 7. It's going to bother me later, but it's fine. Okay, so drop down the 3, and then we multiply and add, multiply and add, multiply and add. So multiply that's 6, add that's -1. Multiply that's -2, add that's -3. Multiply that's -6, add that's +1. Multiply that's 2, add that's 0. Hey, we did it. So this is x minus 2, and then 3x to the third minus x squared minus 3x plus 1. Can you kind of see how this is going to be factored by grouping as it goes 3, 1, 3, 1? Maybe, I don't know. I can tell. Okay, so I factor by grouping because there's 4 terms here. So I have x minus 2. And then in here I can take out an x squared and I'm left with 3x minus 1. X squared divided by x squared is 1. And then I can take out a negative because I want the same thing, 3x minus 1. I scared myself there for a second. Okay, so then I have x minus 2 times 3x minus 1 times x squared minus 1. Wow, that's another one of those that I can factor. -1 and 0, -1 and 1. So I have x minus 2 times 3x minus 1 times x minus 1 times x plus 1. That's terrible. I wrote all over this thing. I'm going to fix it. Hold on. Okay, I fixed it. That's really bad. Okay, I'm going to use this space over here to do one more, or maybe 2 more that look kind of like a x, or look like quadratic but aren't really a quadratic because that confused you today in class. So let me find a good example for that. All right, we're going to factor this one now. This one has 3 terms, so it's probably an x puzzle. Let's try it. -20 and 1. And I kind of know, again, it's an x puzzle because this is twice this one, or half the other way. Okay, so -20 is 10 times 2, which doesn't work. 4 and 5. So 4 and 5 are pretty close to 1, and if the 4 was negative, those would add up to get 1. So this would normally be x minus 4 and x plus 5, but because the squared is here, it actually is x squared minus 4 and x squared plus 5, because x squared times x squared makes x to the 4th. Okay, and then actually x to the squared, x squared minus 4, I can keep going. That's -4 and 0, which is -2 and 2. So I get x minus 2, x plus 2, and then x squared plus 5. That's my final answer. Let's try another one. Let's try this one. X to the 4th minus 7x squared minus 18. Okay. Again, there's 3 terms, so let me try an x puzzle with -18 and -7. And what multiplies to get 18? 9 times 2, or 6 times 3. 9 times 2 is the better deal for the -7. And if the 9 was negative, that would work. So this would normally be x minus 9, x plus 2. But because it's squareds, then it's x squared minus 9 and x squared plus 2. Hey, x squared minus 9. That's another one we could do a little x puzzle for. So -9 and 0 would be -3 and 3. Which means this is x minus 3 times x plus 3 times x squared plus 2. Neat. Let's try another one. I think this is the last one. I'm getting tired. Math for 20 straight minutes. Ugh. What are we even in class normally? All right, let's do, x cubed plus 4x squared plus 4x. This is one I can actually take an x out of, and I'll be left with x squared plus 4x plus 4 instead. Then I can factor this using 4 and 4, which is 2 and 2. So I get x times x plus 2 twice, or we could write it as x times x plus 2 squared. It's the same. I prefer the shorter version. Mathematicians are lazy. Okay. Please tell me if you want more examples. I will do more examples. I'm hoping that verbally helped you with all the steps. But if it didn't, remember that the steps are also down here. They are an option down here. So like if you click on it, it'll be the steps for each one. That's all she wrote. Okay, I'll see you in class. Have a great day. Goodbye.